Hello again, and this is Mrs. Raro, and in this video I'm going to show you how to apply inverse trig values. Alright, so again, these are word problems that deal with inverse sine, inverse cosine, and inverse tangent. Alright, so let's begin. So let's just say we are playing soccer, and Ronaldo is 26 meters from the goal line. So this is Ronaldo. He's 26 meters away from the goal line, so this would be 26 meters. And then he shoots the ball forcefully at a goal, and the height of the goal is 2.4 meters. So from here to here is 2.4, right, which actually creates a right triangle. And then what is the maximum angle of elevation at which Ronaldo can kick the ball and still score a goal? So what angle should he be focusing on so that he can kick this ball and then doesn't hit the top of this goal and actually goes in? All right, so here's a diagram. This is 2.4 meters and then this is 26 meters. So in order to find this angle, we need to use either inverse sine, inverse cosine, or inverse tangent. All right. So in this case, I'm going to be using inverse tangent. So tangent of the angle is equal to opposite 2.4 over adjacent, which is 26. So if I reverse it by using the inverse, then I'll be able to find the angle that Ronaldo should use. All right, so I'm going to go into my calculator, and I'm going to do inverse tangent. Oh, first, let me just make sure that it works. So tangent 45. Should be 1. Okay, so now inverse tangent of 2.4 divided by 26 meters. That should give me the angle of 5.27. So at most, it should be only 5.27. Okay. This angle, it should only be 5.27 degrees. Otherwise, anything above that will hit the top of the goal post and not go in. All right. Okay, I hope that was nice and easy. Here's the next one without a picture. So it says you lean on a 20-foot ladder up against a wall. So you have to draw it. So here's the wall, right? And here's the ladder. Right, it's not perfect, but here's a ladder. Let's make this bricked walls, right? Okay. And then so it is 5 feet away from the edge of the wall. So this is the edge of the wall, and then this is where it's sitting or setting. And then so that's 5 feet. What is the angle of elevation created by the ladder and the ground? So this is the ladder and this is the ground, and this is the angle of elevation that they're looking for right here. Okay, and then I forgot to mention that this is 20 feet. 20 feet. Okay, so now we are going to identify which inverse are we going to use, SOHCAHTOA or TOA. All right, so in this case, we're going to be using TOA because this is 20 feet is opposite and 5 feet is adjacent. So we use tangent of theta is equal to opposite, which is 20, and over adjacent, which is 5. So we're going to use inverse tangent of 20 over 5 and see what our angle looks like. Okay. So inverse tangent of 20 divided by 5. And that's going to look like 75.96. So 75.96 degrees. 75.96 degrees. That's a really high angle. 75.96. All right, cool. Let's move forward. And this is my last example. It says the Sears Tower in Chicago, Illinois is 1,451 feet tall. So again, same idea. Here is a tower. Okay. And then the sun is casting, gotta draw a sun. So here's the sun first. All right. And then this is the tower. Okay. And then it's casting a shadow. So here's it, and then here's the shadow. This is the shadow. Okay, on the ground. I should label it shadow. And then it says what is the angle of elevation created by the tip of the shadow and the ground. So this is the angle that they're talking about right here. All right, so we know that it is 1,451 tall. So this is 1,451 feet tall. And then the shadow is 450 feet. Oh, okay, so we're going to use tangent again. So katoa, and now we're going to use tangent of the angle, which is equal to opposite, which is 1415. Oh no, 1451. Okay, so 1451 divided by its adjacent side, which is 450. So we need to inverse tangent and then figure out what is the angle of elevation created. So 1451 and 450. So inverse tangent 1451 divided by 450. Okay, let's see, 72.77. So this angle is 72.77 degrees. All right, thank you so much for watching. Have a good day.